Hey guys, this is Pwn Depot. We're going to be doing a Keygen today. This is the first video of my Keygen series. The Keygen, or program that we're going to be doing is called ICE9. This is what it looks like here. It's by Triple Tordo. Tools we're going to be using, we're going to use a little of IDA just as a static disassembler. I like the graph view. It helps me understand the program flow, and then we're going to be using X32 debug and PEID. So let's jump in. So the first thing we're going to do is open up PEID and get an understanding of how this program was made. So if you drop this program on PEID, it will show you what it was compiled with. It looks like it was, well, assembled rather. This is Microsoft Assembly 32, and there's a plugin for PEID called the Crypto Analyzer. This analyzes the cryptography signatures in the program, and it looks like there are no signatures found, which is good for us. It means it's probably not packed or got any kind of encrypted strings or anything. So before we start going through the debugger, I'm going to open up IDA. I'll close out of PEID. Oops. And we'll click New, open up ICE9, choose Portable Executable, and click OK. Alright, so this brings us to the entry point of the program. This is the first code that gets executed. As you can see on the side, there's not very many subroutines, so it's a pretty small program. And if I'm going to minimize this, I'm going to open up ICE9, and if we type in just whatever, it shows what's called the bad boy. So in cracking and keygenning, bad boy message is a message that says, hey, the serial was incorrect, or any kind of general error message. And then the good boy is, oh, hey, the program's registered, or whatever. So what we can do with this, for easy programs like this, where strings are stored and they're not, like the program's not packed, the strings aren't obfuscated or anything, we can search for this pretty easily and then kind of backtrack from there. So in IDA, if we go to View, Open Subviews, Strings, we can see the message here, hey, you are okay. If we double click that, it'll take us to where it is. This section of the program is the data section, so this isn't the actual code that gets executed. This is just where the string is stored. So if we right click it and we go to List Cross References 2, we can see it's referenced here. It's being pushed onto the stack. If we double click this, it'll take us to the subroutine where this error message is actually shown. So if we go up to the start of this function, or this subroutine, we can rename it. So just kind of briefly looking at this assembly code, we see the good boy, quote unquote, right here. So most likely this subroutine is the function that checks if the serial is good or bad. So we can rename this, we'll call it serial check. And what I wanted to do in IDA was, this is one way to get to the serial check program, but since this is a smaller program, I wanted to start from the entry point and find where serial check is called from there. So if we go to start, this is the start, like the main function, we can see there's only 3 calls, and one of them is exit process, so we can cancel that out. One is get module handle, and the other one is dialog box param. If we double click either of these, it doesn't take us to any useful code. I'll double click this one, same thing, doesn't look very useful. But we do see this function here called dialog function being pushed onto the stack. And it's being pushed onto the stack for this call. So let's find out what exactly that does. So I have MSDN up, and this is the function that is getting called in our program. If we go back, if you remember, parameters are pushed right to left onto the stack. So this parameter is the second to last. So if we go here, this would be the one being pushed onto the stack. It says a pointer to the dialog box procedure. So for more information, click here. It says application defined callback function. Okay, so it's a callback function. It's being called after this call is made. If we double click this, it takes us to a subroutine called dialog function, and here is probably where we are going to find that serial check function that we just took a look at. If we click here, this is an easy way to find it. I can already see it right here, but if we click the serial check subroutine, right click at the top and go to list cross references to, it says right here it's being called in the dialog function subroutine, and double click it, it'll take us to that. So that's how we get to the serial check from the start of the program. It's a lot of programs, they're much bigger and more complex. It's probably easier just to go strings, and you know, there's other methods to finding the correct subroutine. Another thing I wanted to point out is this is debugger present, and typically this is used as a pretty primitive anti-debugging technique. We could click this and right click, list cross references to, oh, maybe not. Okay, we could click this right here and list cross references to, and it'll show us where in the program it's being called. If we double click this, it's being called from the function we were just looking at, dialog function, and it's comparing if it's true after the call. Remember that return values are stored in EAX after a call is made. So most likely this is going to jump to some function that's going to exit the program. Maybe this, maybe somewhere else. Let's go ahead and open up X32 debug and see what happens when we try to load it. Okay, so I have X32 open. Let's go ahead and open ICE9. Click run. It's going to breakpoint at the entry point. If we click it again, it just exits. And so if we find out where is debugger present is being called, press spacebar to jump between the graph and the text view. We can see the relative virtual address right here. 4010, oh what, wrong one, 401069 is debugger present. So let's restart this and let's try going there. Alright, so we're at the call. Let's try changing the compare to 0. So it's gonna, if it's false, then it'll not jump to the, or not execute this in dialog function. So if we try executing it, it shows up right here. I had my old one open. Oops. So that seemed to do the trick. Now, when we're going through that serial check subroutine and reversing it, we may have to restart the program in x32, and it may get annoying because when you restart in x32 debug, it doesn't save your changes. So we'd have to go into the is debugger present and change it to compare. So what I'm going to do is patch the file. Typically you try to avoid doing that when you're keygenning, because you're trying to write a keygen, you're not cracking it. But it's just one little change and it'll save you a lot of headache. So after you've made the change to the compare EAX after the call to is debugger present, if you just go to file, patch file, we only have one change. We click patch file and I'll call it ice9 patched.exe. Alright. And we'll go ahead and open up that one, so when we restart it'll use that one. And it's asking to restart it as admin, I'm not sure why. Alright. So now we can start trying to figure out how this program is generating our serials. So click run. And I guess we could go to the serial check and just jump here, 401153. Okay. So I'm going to put start of comment. You can press semicolon to create a comment. Start of serial check subroutine. I'm going to put a breakpoint at the start of this subroutine so we can step through it. What I like to do before I start reversing a keygen, or reversing a program to make a keygen, is I think it's called serial fishing. And it's where you look for a serial in a debugger and just kind of copy and paste it into the program. I guess it's for people that don't want to write a keygen but are trying to look for a serial in a program because they don't, or they just want to activate the program and not go through the work of creating a keygen. So we'll run the program, type in whatever, click check, and it breakpoints at the what we believe to be the serial check subroutine. Alright, so we can step through it, press F8. And another good thing of kind of stepping through it before you start reversing is you kind of see the flow of the subroutine. So like right here we see there's a loop. And it looks like it's stepping through each character in our name that we provided. And now it's doing some math right here, multiplying, subtracting. And there's another loop. Not exactly sure what it's doing. Looks like it's concatenating some kind of serial here. And then we get to this string compare. It's taking the serial that we provided and comparing it to this. So this might be the serial we're looking for. If we copy that, usually open up Notepad. Alright, let's try it out. So if we just click run, it'll tell us, okay, not the right serial. Let's try this one that we found. Oh, forgot the breakpoint. Okay, ooh. It's saying that we have the right one. So now we know what to look for when we're reversing this program. Oh, wow. It closed out on us. I guess when you type in the right serial, it exits. So let's restart. Click continue. Type in whatever again. Alright. So we're breakpointed at the serial check subroutine. Let's start stepping through this. Okay, so I'm going to try to comment as much as I can, so then when we're writing our code, it's a little easier to do. So here it's taking the string length of our name, so you can see here it's pushing our name onto the stack and then calling string length. So string length is going to be stored in EAX, and then here it's putting some address into EDX. We can see the address here, and then it's putting EAX. The brackets mean go to that address. So we're putting at 403.16a EAX, which is 9, our string length is going to be stored. And now it's taking our name and putting it in EDI. And ESI is going to be this address. So I forgot to mention at 403.16a, since we know that our string length is being stored there, what we can do is if we right click and go to label, and we click label this address, we can name it string length. So that way every time it shows up, we'll know that it's referencing the length of our string. So here it's clearing out EAX, EBX, ECX, and EDX. Just copy this. And then it's moving our string length into EDX, or at least the address of it. And then here it's just dereferencing EDX. So should change to 9. And then this is the start of our loop. You can see here that EBX is being added by 1. EBX is 0 right now, so I think it's safe to say that EBX is being used as a counter. And then here it's comparing EBX with EDX, which is our string length. So we can just say EBX is counter. Let's step through this. It jumps down here to the end of the loop if it's equal. So it's definitely a counter. And then here, it's taking the first byte where EDI points. So EDI is 4030B4. It points to, or the value of 4030B4 rather is our name. So it's taking the first byte, is putting it in AL, which is the lower bits of EAX. We should see P. 50 is the ASCII for P. Then it's comparing it with hex 5A. What a compare does is it's basically a subtraction. It takes the first operand, subtracts it from the second, and then sets flags accordingly. So the jumps are jumped based off of the flag set. So this is a less than or equal to. So basically what it's doing is if AL is less than or equal to 5A. And so in this case, AL is less than or equal to 5A, so then it jumps to another compare and does the same thing, AL minus 5A, and this one is a jump greater than or equal to. So if AL is greater than or equal to hex 5A, and then this jumps to another jump. Oh, we didn't take that jump. Okay, we took the first one, not this one. So then here it adds 2C, hexadecimal 2C. I guess it's worth mentioning that all the numbers you see here are hexadecimal. Okay, so then this, it adds 2C, jumps up here, then it adds ECX, or adds whatever's in EAX to ECX. And so, even though we added 2C to what our original first character was, a lot of times in keygens there'll be another register or variable or something that stores kind of modified values. And so what I like to call them are modifiers. So I'll say up here ECX is modifier. So then I'll just say modifier is EAX is added to the modifier. And then we increase EDI, which is just getting rid of the first character. And then we jump to the start of the loop again. And then we do that again. Oops. So compare W to 5A, and this time the jump's not taken. So it jumps, oh, it doesn't jump. It adds EAX to the modifier, so whatever the W is in hexadecimal, increases the next letter, and then jumps to the start of the loop. So we'll step through this. We already have the logic, so there's no point in going through it over and over again. Alright. Oops, kind of went too far. So then here it's pretty straightforward. Modifier is 298 is added to the modifier. Here, same thing. Hex 30, 39. Subtracted 17. Another multiplication. Then here it clears out EBX, which was previously our counter. Moves ECX into EAX. So ECX is our modifier. Okay. Then we move hex A into ECX. Okay. And then we clear out EDX. And it looks like this is the start of our another loop. Start of loop. Alright. Now, a divide with one operand. Here, let's step through till we get there. Divide, it will take EAX and divide it by the operand given and store the remainder in EDX. So that's important to know because it's doing something with the lower bits of EDX, which is important to the loop and how the loop works. So we divide EAX by the hard-coded A, or hex A, 10 in decimal, and stores the result in EAX. So this is basically doing EAX divided by ECX, remainder, and EDX. Okay, so we see ECX doesn't change, but EDX has changed and EAX has changed. So then the remainder, we add hex 30 to it. And see this changes to 38. And now so we take the remainder and we put it into 1 byte at a time, starting at the address that we moved into ESI at the beginning of the subroutine. And then here we're adding EBX plus 1, so here's EBX. And so each time we go through the loop we add 1, so we're just adding 1 byte to ESI each time through the loop. So we can see down here, if you right click on the address and click follow and dump, you'll see that the remainder 38 from EDX gets placed there. Then we add 1 to EBX, and it looks like we're comparing EAX, which was the value we got from all these calculations right here, and then comparing it to 0. So each time through the loop we're going to be dividing it by hex A until it gets to 0. So then it jumps out of the loop if it's equal to 0, else it jumps to the beginning of the loop. So here we're clearing out the remainder. Let's add that. Dividing EAX by 10, or hex A, putting the remainder in EDX, adding 30 to the remainder, and then storing that value, the remainder plus 30, into this location right here. Adding EBX, so we'll say EBX is counter. And then checking if EAX is 0. So it's going to do this over and over, filling out these bytes right here. And then now we're out of the loop. So here, let's click follow and dump. It's moving this address into EDI. Not sure what that address is for. Now it's taking the address that we just filled out, ESI plus EBX, which is the length of our, it's the length of our name and also the length of the amount of bytes that we filled out. And then subtracting 1, so that'll actually take us to the last byte that we filled out. And it's moving that into AL. And it looks like this is the start of a loop too. So it puts that into EAX or AL. It moves that into the value where EDI is, so that's the address we're looking at in the dump. And then increases EDI, so we'll go to the next byte, then decreases EBX. Okay. So that'll go to the previous byte, where ESI is. So basically what it's doing is taking that sequence of bytes that we just filled out from the previous loop, from here, and it's reversing it. So what we're doing is we're stepping through each byte in reverse, so ESI plus the length of it minus 1, and then we're decreasing EBX each time through the loop. So that'll give us the previous byte. And then we're storing it at EDI. And that's why we're increasing EDI, so we can go to the next byte. So we'll see here, we'll see this get filled out. 3138. We can see here the ASCII is reverse of ESI. So we have 185, and then it'll be 2, then 1, and so on. Okay, so I'm going to set a breakpoint here and run it just so we don't go through the loop 100 times. I'm not sure what this does. Yes. So we're moving. Looks like our name. Yeah, let me look up here. 4030B4. I guess we forgot to label this at the beginning. If we go to label 4030B4, we can put name. That way we know for sure it's our name. We're loading that into EDI. And then Okay. So we know that name, the address of name is 4030B4. So 4030B7 is 3 bytes in front of where our name starts. So that's why we're seeing the first 3 characters are not showing. And so we see that being pushed onto the stack, and the serial that we generated from all of this code. And so don't exactly want to reverse things that we don't have to, since we know we get the correct serial from this string compare. We can take a guess at what this call is doing. If you remember what our serial looked like, it was this, and then we add on my name minus the first 3 characters. I'll take a wild guess and say that it just concatenates that with this. It did add it on to that sequence of bytes that we were messing with. So then here is our correct serial that they do the string compare with to see if it's the correct one. So I have a pretty good idea of how the logic of this is working now. I think it's safe to move on and start writing some code. Have Visual Studio open, we'll go to File, New Project. Call this ICE9 KeyGen. Add our main CPP file. And then I like to do kind of a split screen view with the debugger over here. Just make it easier to kind of go between the two. Oh, maybe not. We'll make it work. Okay. So let's go to the start of this subroutine. Oops. So it starts here. And then we'll make like a little skeleton program. Alright. And we know we need the name in order to generate the serial, so just say name. We'll make it 1024. It's plenty big. And then the first thing it's doing is it loops through, well, I guess the very first thing it does, it takes the string length, so we can get the name from the user, and then, well, let's make all our variables up top. And alright. And after it gets the length, oh wait, herp. We'll initialize it to 0 and then get the string length. Duh. brain is half working right now. Okay. So then it's the start of the first loop, and it doesn't really matter which kind of loop you use, if you use a for loop or a while loop, as long as the logic stays the same. So we see that EBX is the first thing that happens is we add 1 to EBX. So the counter is 1 at the beginning of the loop. But if we're going to be accessing the character array, that is our name, it's easier to do with a index of 0. So I'm going to create a for loop, and you'll see in a bit why this is probably better to do. If you go in like an IDA, I'll show you. If we use the disassembler, it's probably going to look a little different, but I'm not trying to do a kind of one-to-one translation of the assembly to C++. As long as the logic is the same, it doesn't really matter. Like here it uses a while loop. I prefer for loops most of the time, but I think it's a little easier to do it this way, but it doesn't really matter. So we're going through each character in our name. And then so here we're accessing the first character, and then we do a comparison. So it's a jump if less than or equal to. So if less than or equal to hex 5a, and the first letter, or each letter, is greater than or equal to, oh oops, did I really put 5a down here? Meant to be hex 4.1. Then it jumps here and adds 2c to our first character, then jumps up here and adds ECX to it. So we need a modifier variable. So let's include windows.h so we can use things like dword and stuff. Do dword modifier. So it adds 2c to AL and then adds that to ECX. So we can say modifier equals name I. We need to, actually no, that should be fine. Okay, and then if it's not less than or equal to 5a, or greater than or equal to, or and greater than or equal to hex 4.1, then it just adds name I Is that right? Yeah. So it does this regardless, but if it meets that criteria, then it adds 2C to it before adding it to the modifier. And then comes down here after the loop. So what I like to do is kind of break it into chunks while I'm writing code. So like the first loop we just wrote. So I kind of like to step through it and see like both at the same time and see if I got it right. So we forgot. It's really this. Okay. F3. So yeah, now it should F3 161 1C5 235 29A 30A 379. So it's at the end of the loop at 379. But if you look at EAX, which is where the character from our name goes to, it doesn't do the last letter. And it's because EBX is added at the very start of the loop. So what we need to do is subtract 1 from our string length. And that should give us the correct logic. So now down here, it's pretty easy. It's basically what I wrote in the comments. 29A. Visual Studio's lagging on me. I'll just type it out. Hex 3039 17 9. Okay, so let's go down to here. Oops. And see if we have the right one. So again, we're looking at ECX. Oh, that is right. Okay. So now we have this loop. Which I'm going to use a do while because it is executed at least once. And, that just makes the most sense to me. So the condition is EAX is greater than 0. So let's see. Okay, so we need to make another variable, and I'm going to use something called a stream reader to create our string that's going to contain the serial, just because it's easy to work with. We're going to create it's going to be an O stream. Okay, it's going to be O string stream. Oh, I'm going to just change this to the L string length, just because that's the one used in the program. Okay. So the condition is that remainder is greater than 0, so or not remainder, but I guess we're dividing the modifier. We'll say modifier is true. Okay. While modifier. So we're doing a division, but in assembly it takes the remainder. So what we can do here, there's probably a better way to do this, but this is most convenient. Remainder what am I doing? Modifier modulo. We'll use the modulo operator to get the remainder, and then modifier hex A. So we get the remainder, and we add 30. Hex 30. And then here it's moving it into that, guess you call it a byte array, a sequence of bytes. So then we can do not sure why we're still debugging. Okay, OSS char remainder. So we convert it to an ASCII character, and then we're going to add it to our string stream. And that should be it for that part. Let's see. If that works. Modifier looks good. The remainder, yep, if I remember correctly, is 3.8. And 8 gets put to the stream. F10. 8.6. C. Eight, 6, 0, 8. Yep. Perfect. And now we go to the next loop. If you're wondering here, it already shows it, even though I'm looping through. It's because I didn't actually restart the program. If you just run through it, since it's using a static address, the previous serial that it generated is still going to be there. So that's why I was saying at the beginning of the video, patching that is debugger present, since you might be restarting it. At least I did, to clear out the previously generated serials and stuff. It's a little easier to understand when you're stepping through it, and it's annoying to have to patch the program every time you restart it. So let's go on to the next loop. Here, I'll set a breakpoint. Okay, so forgot we need to add another variable. Just call it serial. And then down here we need to add serial OSS. Okay. And then the next thing we do, this reverses it. Guess I should have reverses modifier. This is not really modifier, we'll call it serial. At the last loop, it pretty much starts generating a serial. Okay, now there's a C++ function called reverse, and we can pass it serial.begin and serial.end, and that saves us a lot of lines of code and does all the hard work for us, and so that should just reverse what we created from this loop. So we can go ahead and check it. And it looks like it reversed, and even though we haven't started this loop, it saved the serial from last time. So 172 blah blah 068 looks good. Now the last thing we need to do is get rid of the first 3 characters of our name. So we can do, well, the first thing we need to do is clear our stream reader. I think we can do it that way, and then we'll make a for loop less than length, and then let's see here. I guess we just pass the stream reader name I, and then we'll concatenate serial with what's on the stream reader. Let's see if that works. Look at that right here. That looks good to me. So now maybe make this a little more user-friendly. cout inline. Actually, we'll do it down there. Maybe see how that looks. Oh, we can, I know this is kind of frowned upon doing it this way, but it's quick and easy. So, Pwn Depot, oh come on, it's serial. Guess we have too many inlines. I guess when you press enter it goes through a new line, so I'm taking this breakpoint off. Let's try it out. Okay, we'll try it with our non-patched one here. Exit out of this. Sweet. Now write a keygen. We just did, bitch. We'll try it with a different name. Make sure. Rake is gay. Nothing new there. And bam, it works. Awesome. So I highly recommend that you try doing this on your own. Maybe use this video as a reference. If you need any help, I'll be posting this on guidedhacking.com and on my website, pwndepot.com. So feel free to post a comment or DM me if you need any help. And yeah, I'm going to be working on another video. It's going to be a little harder than this one. And I hope to see you in the next video.